working. So today's lecture, I'm planning to cover 3 blocks of things. Firstly, I'm going to tell about data normalization. So first normal form, second normal form, and third normal form. After that, I will cover a little bit of data structures in P-cycle PG2. So which type of input should you deliver to P-cycle PG2 in order to work? Otherwise, it will give an error. I will also cover Python placeholders. That it's a thing that some students have trouble because there are some differences between the Python placeholders and the way that Cycle PG2 works with them. And I will also cover a little bit about NumPy and pandas and how they can be stored in a table using Cycle PG2. And lastly, I will talk about assert statements. So I will share my screen now. I have a Jupyter notebook here that I have prepared for you. Just a second. You see? Michael?
Mm-hmm.
Yep. Okay. So why should we normalize the data when we are working with relational databases? So one thing that for me, especially, it's very important, it's database design, because I always try to imagine an application where a lot of transactions are happening in a daily or even a minute basis. So in databases like this, the amount of data scales very, very fast. So you need a lot of storage capacity in order to keep all this data and all this data stored in a database. So normalization, it's a technique very important because it has 2 main advantages. Firstly, it reduces data redundancy, and therefore you reduce the demand for storage to store the data. You also make impact in the data integrity, because to make changes on the data, you have only to change it at one place at a time. You don't need to change in multiple places. And here I have a data set that is not normalized. It's very similar to the example that Amanda, I believe, has given in the course. However, instead of working with musical data, we are going to work with medical data. So imagine that you are the database administrator from a hospital, and someone wants you to create a database for them. Which issues can you see here, Michael?
Mm-hmm. So there's like the medical prescription is an array.
Yeah, that's one. There's another one.
There's some duplicates, like doctor name and doctor specialization get duplicated. So those are things that could be moved to different tables.
Arrays. That's the other one. Duplicates at the columns. And go. Specialization. There's another one that needs to be handled at when you are going to transform the data from unnormalized to the first normal form. That is the address right here, because if you have to make insertion, you will need, for example, imagine that Marcos Paulo Gonzaga makes another 2 appointments, so he will have more two rows right here. But suddenly the Marcos Paulo changes its address, so we will need to change both the row 2 and the row 5 and 6. So this is another issue. Or for example, if Yana Markovic needs to, for some reason there is a mistake and we need to get rid of this row right here, we will lose all the information about this patient, because the information of her is not stored somewhere else. That's so in the first normal form. How would you organize to make this data into the first normal form? If you need it, I can help you.
Yeah, so there's so the two easiest things are getting rid of patient name, patient address, moving that to a separate table, and then instead using a foreign key to point to that table. Do the same thing with doctor name, doctor specialization. And then for the prescription, I mean, that one's a little fuzzier for me. I know it would want to be a separate table where I think the column would be a reference to an appointment, a reference to a patient.
Yeah, there's no right answer here. For example, but you are correct about the patient address. The doctors doesn't need necessarily to be handled right now, but if you want, it's possible. It's not mandatory because they are not. For example, in this case, I don't think the doctor is going to change his specialization or his name. But in other situations, for example, if you had the doctor address here or his telephone, would need to be carried out in the first phase as well. You got it? So, in the medical prescription, in the first phase, we just transform this into new rows, because the step to make this a separate table occurs usually at the second, when you are the first normal form and you want to transform it into the second normal form. So here I have created the so as you can see now, instead of 5 rows, we have 10 rows. And I also have created a foreign key in the appointments to be able to access the patient's table. I've done this like this because, as you can see, this is a one-to-many relationship. One appointment just have a patient, but a patient can have many appointments. So now going to second normal form, where you're right about the medical prescriptions. So here we have an ID for the. It's that what you meant, right?
Yeah.
An ID for the medical prescription, another for the appointment, and the medicine that was prescribed for each patient. So just to be sure, let's make a join to see if the data was lost this way. Second. People hasn't changed. Something's wrong here. Enable it. When I saved the final, I didn't save the index of false, equal false. Better like this. Opa, something is wrong. appreciate it. I believe that I mess up the data. Some case. I know what is happening. It's because this data, even though it's on the file, it's in the first normal, second normal form, it's in the first normal form yet. So this is why it's happening this. Let me get the last one. But basically, it's going to work. Sorry for the delay. Search pages. Oh. And now it's correct. It's 10 rows. So in the third normal form, it's more simple. It's just about transitive dependence. So, and the other complication is that you have addressed as well. It's the duplicates inside the columns. So we can basically create a table for the doctors with their specialization and their name, and to create a foreign key in the appointments table. Like this. So this is the appointment table. This one's the patients. The name doctors and the specialization. And the medical prescriptions. Do you have doubts about this piece of the presentation, Michael?
That really looks good to me.
What?
That it looks good to me.
Looks good. Okay. So in this part of the presentation, I was planning to do a game between two persons, but I just let me see because there's something on Slack. Maybe it's a student. No, it's not. This is me trying to do the presentation before. But basically, I'm going to ask about these metadata structures in PsychoPG2. Most of this material I look at the documentation of the library. So, and I have adapted for this this webinar. So I'm going to ask you if this if each piece of code is going to execute or it's going to throw an error, and ask you to justify why this is happening. If I will complement your answer if you make the correct choice. Okay. So
where is the table created?
Yeah, we will import right now.
Okay.
So as you can see, the table has just one column. It should hold an integer. And here I'm trying to insert this value on the.
That one should work.
Actually, not, because PsychoPG doesn't, because first int doesn't support indexing, but actually PsychoPG just accepts tuples, 1D NumPy arrays, and lists. So it doesn't work, because even though this looks like a tuple, if you do this, you get an int.
Oh, interesting.
And this.
So then that one would
work.
Yeah.
Why do you think?
So that comma might be enough of an indicator to make sure that it knows it's a tuple, not just an int.
Nice. That's the answer. You're correct. This one?
That one I don't think would work. Because the data type is wrong. I don't know if it accepts list or not. But it's a different data type, so I don't think it would.
Actually, it works because this is a list, as you can see.
And so lists are acceptable?
Yes, these are acceptable. Lists and tuples. And this one?
I would assume doesn't work.
Doesn't work? You are correct. Because this is the same case as this one, just written in as this one, just written in a different way.
Mm-hmm.
Are you aware of this type of nomenclature?
Yeah.
For example, what is going to what's going to be the output of this function?
That one should be hello.
Yep, correct. This one?
I think this is a string version of 12.
Yeah.
I think that one is also a string version of 12 without the decimal. Oh, no, it does put the decimal. Okay. And then, 3 times. I don't know. I would assume that that's an error unless Python handles multiplication of strings.
Yeah, it's the second option. It will concatenate the string. So
Okay.
why did I put how this code chunks right here? It's because I want to show you that this percent %s, it's very flexible.
Mm-hmm.
And none of these yields errors. This one, what do you think gonna happen?
I would think that one would fail.
Yeah, you are correct, because this percent %d, it's meant for digits. So
Mm-hmm.
it accepts integer or floats. But if you pass a float, what is going to happen? He is going to convert the value to an integer. And this one?
Will convert to a float.
Yeah, are correct. So the cycle PG2, it's a little different for Python. For example, here I have the same value. 111, it's a tuple, so it shouldn't make an error. But which pieces of code do you think will execute and which do you think will not?
So I think the first two will work because it'll treat the value that's being added as an int, which will work. But I think the last one gets converted to float, which conflicts with the data type on the column.
Yeah, that was what I expected too. However, the only one that works, it's the first one. You can see here. Happens because Psycho PG2 doesn't accept the percent %d and the percent %f. In the documentation, I was laughing because they have said, and never do this. So it was really strange to me because I thought it would work. So this table doesn't exist yet. Now jumping to pandas and NumPy. We are going to use the table of medical prescriptions. As you can see, the type is a core, it's a data frame. And do you think that this code is going to work or not?
No, it has the same. Trying to insert into the same column twice.
Yeah, you're correct. Won't work. Because PsychoPG2 doesn't know how to deal with multi-dimensional table, except if you if you use a CSV file to do that. So if you want to import a pandas data frame, you have to iterate over the rows. So you usually use iter rows. And this one is just for doesn't need this code. Basically, you can convert each of the values in a tuple, inside a tuple, and you can import it. I also have placed right here a fetch all command. So it works fine. Which type is it's going to be printed? Michael?
Yep.
Which type?
Of raw data.values. Was raw data a CSV? Oh, but it was turned into a data frame. Should be a list of lists, maybe?
Actually, it's a NumPy array because when you pass, we use this type of things a lot in machine learning. But for example, here it's a pandas data frame. But if you want the values, can transform into a 2D array. And do you think that this might work when to insert?
I don't think so. I don't think it can handle the NumPy array data type.
You are correct in this case. And what about this?
So that's interesting. So it'll be, if it's a NumPy 2D array, this is still a NumPy array, which I don't think would work. Yeah.
Actually, it worked because, as you can see here, the array was converted into a 1D array.
So it can handle one-dimensional arrays.
Yeah.
But not two-dimensional. Okay.
It's very. There are a lot of peculiarities to this library.
Yeah, I ran into one issue where it couldn't handle NumPy int, but so you had to like convert to Python int.
Yeah.
Which is weird.
Oh, spoiler. This one, we believe that will work. First, I will create another table of the type int. And after that, I'm trying to insert this value right here.
So that you would imagine would work. The only reason that might not work is if that number's outside of like the range of what Postgres handles as an int.
Yeah, you're correct. It happens because, let me show the documentation. Stress. As you can see, the small int, it's just between 32,000 to negative to positive. This one can handle up to 2 billions because the storage size it's 4 bytes. But if you look at the big int, that's the class type that we need to use in this case, it can handle a lot of a big, really big number. I believe that this is a 996 units. So if we change for example, if we change, let's go to this. It will work. You are used to use Postgres or which type of base do you usually work with?
Yeah, normally Postgres.
So are you aware of the serial data type?
Yeah. Yeah.
So just for the guys that doesn't know about it, but there is a data type that's analogous to other database. Its name is serial, but it's like the auto increment of MySQL and MS SQL Server. Matter of ethics. You can see, even though I didn't specify the value, the ID of the column, that is the sample column 1, auto increment. So if, for example, I toggle this code right here. Now, so we don't need to insert the integer, the ID values. We just insert the values of the other columns inside the table. So the last piece of this webinar, it's about the assert statements. Are you aware of assert, Michael?
No.
Assert, it's a way of data quality check. For example, it's like an if statement, but if the code, if some condition is satisfied, the code executes normally. But if the code doesn't satisfy this condition, the code will stop and it will yields an assertion error. For example, as you can see, this is a list, right?
Mm-hmm.
So you just pass assert and you give a space and then the condition. For example, type of the values is equal to list. If this is correct, this should execute. If not, the code is going to throw an error. The case of that we were using in the beginning. For example, this should throw an error. So when it's useful to use assert statements, it's useful in functions because you can specify some condition and pass an input for the user. It's also useful for you to debug your code. For example, you know which type of input you should pass to a function, but sometimes the code that you are using it's big, so it's not so clear why the error is happening. So using assert statement can be useful in this case. So I have prepared just this. Do you have doubts? There's something that you want me to cover about the first project? I know that you have already finished it, but you may have some doubts.
So the assert was cool because I haven't seen that before. Maybe I think so. I know in there's like a rubric, or maybe it was just in the details at some point, but they mentioned like things that you can do that are outside the scope of the requirements, but that are nice to have. So one of them is insert data using the copy command to bulk insert log files instead of using insert on one row at a time. It might be nice to cover that.
You want me to show to you how to do that?
Yeah.
Okay. It's very straightforward. However, this function it has some drawbacks. For example, your data constraints and how to deal with conflicts in your SQL carries.py should be perfect, because if you have, for example, imagine that your code is executing a file, and in this file there is a conflict. So the code in Python would stop the execution of this file and will start the other, but will not insert the rest of the data inside the file. It was clear? Michael, is it clear, or you didn't?
Yeah.
Yeah. So, some case it was very useful at the project, but in others, only when your code for the carries were perfect. Basically, it's like this. Let me get a file, because I will save it again for you to know how to do that as well. Okay. First, you open the file and you give the file an alias. After that, let me create the table that will store this data. Here you pass the table name, that is patients, and here you pass the set, how the columns are separated in the file. So here, let's start from patients. You can see the data was successfully stored in the table.
Nice.
Any more questions, Michael?
I think I'm good.
So thank you for attending the meeting today. I hope you enjoyed. I have taken some time to prepare the examples right here. And if you have some feedback, you can tell me, because in order for me to become a better mentor in the future. If you prefer, you can do it in private. The recording will be shared with all of the guys in the session channel by tomorrow. So thank you very much.
Sounds good. Thanks for taking the time.
Thank you.
See ya.
See ya. See you.